Full details are uploaded on www.automobilehut.in. The power developed inside the engine cylinder is ultimately aimed to turn the wheels so that the motor vehicle can move on the road. The reciprocating motion of the piston turns a crankshaft rotating the flywheel through the connecting rod. The application of engine power to driving wheels is called a power transmission system. The motion of the crankshaft is transmitted through the clutch to the gearbox or transmission, which consists of a set of gears to change the speed. The vehicles which have front-wheel drives in addition to the rear-wheel drives include a second set of propeller shafts, universal joints, final drives, and differentials for the front units. The function of a clutch. A clutch is a device used in the transmission system of a motor vehicle to engage or disengage the engine from the transmission. Thus, the clutch is located between the engine and the transmission. When the clutch is engaged, the power flows from the engine to the rear wheels through the transmission system, and the vehicle moves. When the clutch is disengaged, the power is not transmitted to the rear wheels, and the vehicle stops while the engine is still running. The clutch is disengaged when starting the engine, when shifting the gears, when stopping the vehicle, and when idling the engine. The clutch is engaged only when the vehicle is to move and is kept engaged when the vehicle is moving. The clutch also permits the gradual taking up of the load. When properly operated, it prevents the jerky motion of the vehicle and thus avoids putting undue strain on the remaining parts of the power transmission system. Clutch operating principle. The clutch works on the principle of friction. When two friction surfaces are brought in contact with each other and pressed, they are united due to the friction between them. If one is revolved, the other also revolves. The friction between the two surfaces depends upon the area of the surfaces, the pressure applied upon them, and the coefficient of friction of the surface materials. The two surfaces can be separated and brought into contact when required. One surface is considered as a driving member and the other a driven member. The friction surfaces of the clutch are so designed that the driven member slips on the driving member when the pressure is first applied. As pressure increased, the driven member is brought gradually to the speed of the driving member. When the speed of the members becomes equal, there is no slip, the two members are in firm contact and the clutch is said to be fully engaged. The driving member of a clutch is the flywheel mounted on the crankshaft, the driving member is the pressure plate mounted on the transmission shaft. Friction surfaces, clutch plates, are between the two members. When the clutch is engaged, the engine is connected to the transmission and the power flows from the engine to the rear wheels through the transmission system. When the clutch is disengaged by pressing the clutch pedal, the engine is disconnected to the transmission. Thus, the power does not flow to the rear wheels while the engine is still running. Requirements of a clutch. Here are some examples of why we need a clutch. 1. Torque transmission. The clutch should be able to transmit the maximum torque of the engine. 2. Gradual engagement. The clutch should engage gradually to avoid sudden jerks. 3. Heat dissipation. The clutch should be able to dissipate the large amount of heat that is generated during the clutch operation due to friction. 4. Dynamic balancing. The clutch should be dynamically balanced. This is particularly required in the case of high-speed engine clutches. 5. Vibration damping. The clutch should be dynamic and balanced. This is particularly required in high-speed clutches. Size. The clutch should be as small as possible in size so that it will occupy minimum space. 7. Free pedal play. The clutch should have free pedal play in order to reduce effective clamping load on the carbon thrust bearing and wear on it. 8. Easy in operation. The clutch should be easy to operate, requiring as little exertion as possible on the part of the driver. 9. Lightness. The driven member of the clutch should be made as light as possible so that it will not continue to rotate for any length of time after the clutch has been disengaged. Main parts of a clutch. The main parts of a clutch are divided into three groups. 1. Driving member. The driving member consists of a flywheel mounted on the engine crankshaft. The flywheel is bolted to a cover that carries a pressure plate or driving disc, pressure springs, and release levers. Thus, the entire assembly of the flywheel and the cover rotate all the time. 2. Driven member. The driven members consist of a disc or plate, called the clutch plate. It is free to slide lengthwise on the splines of the clutch shaft. It carries friction materials on both of its surfaces. 3. Operating member. The operating member consists of a foot pedal, linkage, release bearing, release lever, and springs necessary to ensure the proper operation of the clutch.